Uh, Hello everyone. So today I'm going to present to you my new software. It's about aircraft performance tool. So today I'm going to make some demonstration about how it works properly. So before starting, I want to make some points because you know the software. The purpose of the software is to simulate to make takeoff or landing dispatch. Because in flight simulator game, some user want to use the aircraft performance tool just to make runway analysis, to know what is the maximum allowable takeoff weight or what is the direct takeoff. So this software is not for real world using, so don't be fooled to use this software, because it's just for flight simulator users. So like Pmdg 777-300, Boeing 777-300. So that's I made. So I take this. I choose this aircraft for doing my aircraft performance. So this software is not for commercial use, and the data are not certified for real flight. So don't use it for real flight. So don't be enough fool to use the software for real flight, please. Thank you. So please contact your aircraft manufacturer for using the real aircraft performance tool. That's it. Okay, so if you are clear for that, so that's fine. So let's start now. Okay, so I want to choose an airport. Okay, so let's say I want to choose Dakar, in Senegal, West Africa. So now I got a runway selection 36 today. So automatically I will have engine failure procedure, which is corresponding by this runway. That is a description. So I'm gonna make dry or wet, and so other thing is maybe because there are contaminated runway state. So as flight simulator doesn't simulate like a slush or standing water, so it doesn't matter if you put contaminated runway or not, so it doesn't matter. So that's why I will be limited by runway or wet. That's it. Okay, so now I will make a wind 36, let's say 360 and 8. So now I will get a headwind component, which is 8 knots and 0 for crosswind, and weight is 20, let's say 20, and QNH is 100 9.0. Okay, so I got here the convert altimeter, and now I will make a thrust setting full 10% less or 20% less. Okay, so now I'm gonna use the TO for that moment. So I will put +5. So I will have 15, 20, and optimum is the flag position, which allows us to maximize the maximum the takeoff, the allowable takeoff weight, or the direct takeoff, the assumed temperature. So it's very useful, it's very useful option, though I will show you how it works properly. So I'm gonna make +5, plugs on auto, and takeoff weight is about let's say 250, yes, 250 ton. So now I'm ready for simulating the takeoff, the dispatch, but I prefer to leave blank this area, because I want to know what is the maximum allowable takeoff weight by this configuration I type on this area. Okay, so let's go. Okay, so I got information for +5, 36 for runway, and takeoff ground takeoff weight 342 tons, and the CHO, that's the N1 which is engine rating. So I don't have V speed because I'm simulating only the takeoff weight. So I'm gonna make I'm gonna simulate V1 VR V speed later. Okay. So now I got a 342. So maybe sometimes it's not enough to, you know, if I want to maximize. So maybe I can get higher. Okay. So let's say I will put optimum. So as I said, optimum will maximize takeoff weight, allowable takeoff weight. Okay. So now let's do this calculation. So I got now 352. So 10 tons more. So just to make sure, because here that's a round value. It's about you know, maximum takeoff weight, about the structural, because each aircraft has a limit for weight in structural, you know, in the aircraft. So that represents the MTOW. Okay, MTOW. So now I gonna to so let's say that's optimum. So 15 should be the optimum for that. So why is optimum? So I will show you. So let's say I want to put flaps 20. Flaps 20. So maybe it's not good. Okay, how I can do is maybe to change. Yes. Okay, so let me change the configuration just to show you. So now it's less. So flap 5 represents the lower allowable takeoff weight. So if I want to maximize that, so 20 it should be limited by yeah, it's the same. So both of them, 15 and 20, represent the maximum. So it's limited by the MTOW. Okay, so let me give you another example from another airport. So no intersection for this airport, because this airport doesn't have intersection. Okay, so let's say EGL, London Heathrow. So I will make 09 left. So I will put all, by this case, and optimum. So now I will simulate that. Okay. So now I have the maximum takeoff weight. Okay, it's flat 15. So other nice features for this software is I'm able to have alternate intersection departure here. So it should be less, because it gives us a shorter takeoff length. That's why. Okay, so I have a new engine failure procedure by this airport. So now I will simulate, let's say flaps 5. Okay, so maybe let's say I want to choose a intersection 11 A11. Okay, I got this dispatch show. It's 324 tons. So let's say I want to choose an example. It's maybe an example. Okay, so let's say I want to put optimum. So it's the maximum I can have is 353 tons. So let's say why it is 20, because if I put 50, so it's gonna be less. That is a less, and another should be less than. Okay, so that's why 20 is optimum. So if I choose optimum, they will choose 20 for optimum, because it does represent the maximum allowable we can have by this configuration. Okay, so let's change some parameter. Let's say wet. So I expect it to have lower, so let's say dry. So actually I have 308 ton. So let's say I want to choose it wet, so I'm expecting to have less for maximum allowable takeoff weight, and here that's fine. Okay, so other thing is maybe let's say yeah, so about takeoff, I want to change the wind, for example. So actually I'm on 8 headwind, 8 knots. Okay, let's say change to 20. I'm expecting now to get okay, sorry, get to change. Okay, so I got let's say 317. Okay, so I want to change, let's say to decrease to 0, or maybe it's 5, so it's less. So I'm expecting to have lower. Okay, that's it. As I am telling you, it should be less. Okay, let's say to change the temperature. So if I increase the temperature, so the density is decreasing, then the aircraft performance will decrease, then the takeoff weight will decrease. Okay, it's 40, and that's it, as you can see. So now other thing is maybe the QNH, because QNH is very important, because it does affect the pressure altitude, which is a very important parameter in aircraft performance. So if I increase the altimeter, then the pressure altitude will decrease, and it's favorable for an aircraft performance criteria. Okay, so let's say to put 1020. Okay, so it's update the new one, and I will put so I expecting to have higher, and that's it, as you can see. So let's say I want to change the flaps, no flaps, let's say packs. So packs, I'm going I was on, so I will put off. And if I put off, so there is more engine thrust, because there is no bleed extract, you know, there is no bleed on the compressor, on the engine, so no more thrust, so they will gain on the thrust, you know, amount. Okay, so I expecting to have higher, so that's it. So as you can see, it's very good. So now I present NTI. So NTI, so I put auto in terms of altitude. So if it's higher than 10, they will, so NTIs will let's say will be on, then they will decrease takeoff weight, because there is a bleed engine. Okay, so let's say to put on, so I expecting to have less. Okay, and that's it, as you can see. Okay, so I have another update from other tax intersection departure. Okay, so now let's think this may be a takeoff thrust rating, because I got for thrust 10 or 20% less. Okay, so let's say I want to put to chill on, so obviously it should be decreased, because less engine thrust, so less takeoff weight. So that's it. So chill on, the N1 will decrease, so obviously, so it does make sense for that. Okay, though tier 2, for example, same thing. Okay, so now I will go to maybe to show you another part of the software, which is very important, like assumed temperature, because most of airlines use this option, like to use a minimum thrust, required thrust for takeoff, depending on the runway length, on the climb capability, or obstacle and other stuff as aircraft takes into account during the takeoff. So I will put so assume temperature. If I want to choose that, so I should enter my takeoff weight. So they will give me the assumed temperature, the maximum assumed temperature for that. Okay, so let's say in meanwhile I will change the airport. So Dubai International. Okay, so I will have 1 2 left, and I have a mini intersection. So they will update for that, and I will put ATM for assumed temperature displaying, and yeah. So let's go. Okay, and now I got direct check of is about 17, so that is the limit. So maybe I can choose Tier 1. So I got V speeds, VRF and V speeds. So next section I will show you. I will make a comparison between FMS and V speeds. From this aircraft performance tool. So I got Tier in 1, etc., and new engine failure procedure. And let's say I want to make Tier 1. So Tier 1 is so I want, if I want to combine you know, fixed, direct and assumed temperature, so I will put Tier 1. So they will update. So I got I'm expecting to have 60, so that's fine. So maybe I will use Tier 2, and it should be less again. And so if I want to choose this intersection, they will give me the dispatch for that, or maybe this one. I got 46 degrees, so 35 Celsius, so it's fine. So now I got so other thing is maybe sometimes if you you make shorter your runway length by using other intersection temperature, so this aircraft are not able to take off by this intersection temperature, sorry. So no takeoff. That's clear for that. Okay, so let's say I want to show you something. Maybe it's about SM temperature. Let me something that so now okay, so it's 45, 48. That's good. Okay. So we put white. Okay, I want to show you something, because sometimes it's displaying no ATM, so no available SM temperature. So that's I wanted to show you, and maybe there is a climb limit on the by this configuration, but it doesn't matter for me. Okay, so let me show you other thing. So that's it for this little demonstration. So I will show you maybe show landing. So let's say I want to land on an airport, maybe in Montreal, CIUL at runway 24 and dry and 258. That's fine. And okay, that's fine. 2.35. Okay. And so I will choose a or reverse flaps 40, back is on, and let's say flaps brake from 4, and so I got I include some you know, some non-normal configuration, because sometimes in landing there is some failure, like hydraulic or flaps. So those features will affect aircraft performance. So I will show you later. So let's say I put blank. I want to know my maximum takeoff by this configuration. So I got limit weight for each type of landing, like normal or icing condition or auto lined condition, and quick around weight. So I explain you step by step. So the 251, because it's equal to all of them, 3 of them, because this value represents the maximum structural landing weight. That's why. So if I want to be limited by the landing distance, so I will put auto brake 2, and so they will decrease obviously. So other figures, you got the same thing with ice. So icing condition doesn't affect land, though they will affect. I will show you later. So icing condition will affect only the landing climb limit capability. Okay, and low visibility, why is less? Because in autoline, because the aircraft doesn't perform at the same, you know, if you want to autoline, it is not the same you know, landing capability if you make manual landing or if you make autoline. So it's the aircraft responds differently. So because for that, then like certification, like FAA or Transport Canada, so they will they will ask you to put some margin. So actually I put some margin for that, so that's why it should be less. Okay, and that is a correspond VRF and quick around. So let's to change maybe the gradient, you know, go around gradient. So I put 3.25. That is I type now. So now I want to type let's say sorry, so let's say 8. Okay, so let's say I want to put the gradient. So I want to be limited by the landing climb limit weight. I put 8, so the weight landing climb limit weight will decrease. So you can see that. Okay, let me check. So maybe I will put 4 now. So that represents the landing climb limit weight. So now with ice is less, is 20 tons. So it's less because icing condition will affect the climb, the landing climb limit weight. That's why. Okay. So now I will return to 3.25. So now I want to know my landing distance now. Okay. So let's say I am on the top of descent. So I want to, I take my zero fuel weight and the fuel weight of the weight of the fuel. So I will put let's say 220 tons. So I will put so 0. So they will give me the landing distance. So it's 2625 meters. So in 140 knots. And okay. Yes. So now let's say I want to put I add some VRF increment. I will put increment on VRF. So 5. so I will put 5, so I got a higher and higher landing distance. Okay, so let's say I want to change auto brake 2. Okay, so they will increase, but it's predicted require field length exceeds the available landing distance, so it's not good for me, so I should put 3. So I will be careful about the limitation from landing distance, so that's good. So that's fine. So I show you how it works. So now I am going to the aircraft, so I will show you, I will make you some comparison, so they will you will see yourself what's going on. Okay. Yes, welcome again. So I have a 777-300 in front of me. So now today I am going to present I am ready for takeoff. I am on Paris Airport, Roissy-Charles de Gaulle, busy airport around here. So now I will, before takeoff, so I will have the runway in front of me, which is 08 left. So I will take off, but before that I want to know, I want to use direct takeoff, and I want to know my V speeds, which are very important parameters in takeoff. Okay, so now let's open my program. So airport, I will put LFPG and 08 left, and I have a engine failure procedure here, and intersection should be the Tango 6, and dry and wind I got 010 and 4, and temperature is 16, and QNH 999.0, and show optimum flaps, max on, and auto. So I want to know my takeoff weight, which is 263.6. so I will punch on this field. Yes, so I will put ATM mode for assume temperature, and I will put calculation button. So I got my results here. Okay, so 59 degrees as assume temperature and V speeds. So now I got my so flaps optimum should be 15 and 89.4, but if we compare maybe here, so I will put 59. Okay, so I got so it's a little bit different, about 0.3 of difference on the N1, but it doesn't matter. So takeoff I will put 15, and so now I got my V speeds from the FMS. Okay, so now I want to compare aircraft performance results versus FMS results. So I got VR V2 is good, is 156 VR and 160 for V2, the same here. The only difference is between V1 I got 150 knots and 153 knots here from the FMS. So the explanation is about because the one thing is the FMS calculate the V1 basing on balance fuel length. It doesn't take account a clearway or stopway length on a runway. So but on the aircraft performance it does take into account clearway and stopway. So it should adjust the V1 depending so if I got some clearway length or stopway length, they will adjust the V1, so that's why it should be less, 3 knots less than the V1 from the FMS. But I should choose this one because that's the good. Okay, so let's overwrite the 153 by 150. That's it. So now I got my V speeds, my final V speeds. Okay, so other thing is maybe to, if I want to change to chill 1, so I want to combine fixed D rate and ascent temperature. So put calculation again, 49. So now I will change G rate setting 49, then chill 1. Okay, 49. So now I get 49 from FMS and chill 1. Okay, as here. So I got the same V speed, which is very good because it's this is the same thing, because it's the same minimum thrust required by this takeoff. So it's 150, but it's less because they adjustment on the clearway and on clearway and stopway from the runway length, and VRV2 is the same, so we are good. Okay, and so that's it for this presentation. So I am glad to see the results I check with my aircraft performance tool. So actually I'm on beta testing, so there are some stuff to maybe to fix, so I work on it, so it's still under development. So thank you for watching, and see you again. Thank you very much.